Good evening, folks, and welcome to the Orkney International Science Festival and Foraging Festival online. My name is Julie Rich, and I'm delighted to co-host this session from Orkney. For anyone new just joining us, this is the 30th anniversary year for the Orkney International Science Festival, and what an occasion, being able to deliver the full festival programme to you wherever you are. We have an amazing lineup of experienced professionals in the hydrogen and renewable energy world. It is my pleasure to hand over to my co-host, Carol Ogg, Hydrogen Marketing Officer at EMEC, European Marine Energy Centre. Karen joined EMEC in 2018, where she leads communication for all of EMEC's hydrogen projects and raises awareness of the pioneering work happening here in Orkney to help drive a green hydrogen economy. If you have any questions, please enter these into the YouTube live chat and we'll come back at the end of the talk. Over to you, Carol.
Thank you very much, Julie, for the warm welcome to this year's Orkney International Science Festival. As you said, we've got a really interesting session and speaker lineup for you. Our first speaker this evening is Managing Director at the European Marine Energy Centre and Vice Chair of the Orkney Renewable Energy Forum, Neil Kermode. With a background in civil engineering, he is a very strong supporter of the Science Festival, a regular attendee and speaker, and he will be discussing Orkney's energy past and present situation. Next up, we will have Richie Ainsworth, EMEC's US project engineer. After completing a master's at Heriot-Watt in renewable energy development, he started at EMEC in 2018 and has been a valuable member of the hydrogen project team. He's now moved over to the US, so he's joining us from across the pond, but he'll be discussing hydrogen in aviation and the High Flyer project. Next, we will then hear from James Ferguson, who is tantalisingly close to completing a PhD, an industrial PhD with ID Core and EMEC. And we're delighted that he'll actually be starting a new role at EMEC as an R&D engineer in October. He's also the recipient of the Academic Award at the Young Professional Scottish Green Energy Awards this year. And finally, we will have Gareth Davies, the Managing Director of Aquatera. He's worked as an environmental consultant for over 30 years, trained initially as a marine biologist, and he'll be discussing the Reflex project and the Future Innovation Hub in Orkney. So without further ado, I will hand over to Neil. Neil, the floor is yours.
Thanks, Karen. And I hope you can see the screen share. So good evening, everybody. Thank you very much indeed for the opportunity to speak at the Science Festival. It is a bit strange doing it from a back bedroom rather than the King Street halls, but we'll get used to it. But great to be able to talk again this year. And this year we're going to be talking about Orkney's energy revolution. I'm starting off really to pick up the scene before we go into some more detailed aspects. But the first thing really that is worth thinking about is what is Orkney? What do we know by Orkney? Well, we know geographically what it looks like, and we know where it is. But it is more than just a few spots on a map. It's 22,000 people spread across the 17 islands, and really we've been at this innovation thing for about 5,000 years or so, and we do have abundant renewable resources. We've also got a lot of hydrocarbon reserves around us, and we have made the most of those over the years. We've always been a maritime crossroads as people have come through these islands from time immemorial, and ideas have passed through just as people have. And we've also ended up becoming a centre of excellence through a lot of work that's gone on over the years with local businesses, Heriot-Watt University, University of Highlands Islands, Orkney College, and a load of other organisations and people who have developed extreme excellence in a number of fields. And we are very capable of showing what can be done on a digital platform. We're become an international destination and renowned for food and drink. And believe it or not, we are the UK's happiest and most sustainable community, according to various measures. We do also have amazing ecological diversity and environmental quality, and I would argue we're also a community which is very well aware of its impacts and needs. And the colours at the bottom right hand corner are the Sustainable Development Goals developed by the UN, and Orkney maps on very well to a lot of those. Not perfectly, but it does map on very well overall. And the point is that Orkney is really a place where we've discovered the future is actually happening, and it seems to be happening here before a lot of other places. What do I mean by that? Well, in the energy space particularly, here's one perfect illustration, and that is that this is a graph produced by one of our colleagues in the Reflex project by Solo Energy, which shows the UK electricity demand over the month of August. That's the grey line, August in 2019. And below it is what was generated from renewables in that same period. And you can see it's a squiggly line, and it's very peaky, mainly because that's driven by a lot of solar energy. But the wave form that rises up and down is really driven a lot by wind that was going on. So the question is, what does this look like in a world where we're going to have more renewables? Well, quite simply, if you take the UK figures at the bottom of what is being generated and multiply that by 4, you end up with a graph looking like this, showing that at periods there are times when there are renewables which are greater than the energy demand. There are periods when there is renewables that are less than energy demand. And that's what will happen if we put 4 times the amount of renewables onto the network. But Orkney actually looks like that today. This is a graph from a similar sort of period, just a couple of years earlier, but it's fundamentally the same thing, where the blue line in this case is the demand for electricity in Orkney, and the red is the generation that's going on. And I'd just like to centre for a moment on something here in one particular day, the 28th of August. And you notice in this individual day, this is one day's generation, and you'll notice at midnight when the day starts, the power demand generally increases. It peaks in the morning, it drops off during the day, it then comes back up again in the afternoon, and then tails away as people go to bed and eventually drops down. I will come back to that later on, but that trough in the middle between the morning and afternoon is actually important. So I said we also have a community that knows how it understands itself and has got good measurements. Now, some of you who've been to previous science festivals will have seen this graph before, which is a Sankey diagram produced by Gareth's company Aquatera back in 2015 as part of an energy audit that was undertaken for the Orkney Renewable Energy Forum. And this Sankey diagram shows several things. I'm using this one initially, and then we'll go on to a modern one which has now been produced. But the point is that the middle column shows the fuels that we use to power our economy. And the top section, ringed in red, showing the amount of electricity we use, and the areas are proportional to the amount of energy used. And you can see going down that we use a small amount of coal, the black horizontal line is LPG, and then there's kerosene, gas, oil, etc. Now this was done in 2015, and things move on. And so as part of a project which Gareth is going to talk about later, the Reflex project, this energy audit was redone and a new graphic has been produced, which it goes further because this time it now splits out on the right hand side in greater detail precisely where we're using fuels for different things. So you can see here electric vehicles, there's a tiny line, diesel cars is quite significant, diesel, light goods vehicles, heavy goods vehicles, buses, petrol cars, light good vehicles and petrols and motorcycles. So we can see what we're using in transport in much greater detail than we could before. And this is really important because it allows us to track what changes. But this was done before COVID. And now we are also going to see different changes that are going on with COVID. And we can see that now we know there is more home working. There's less of a daytime trough, as I referred to it before. The gap between the morning peak and the afternoon peak has now filled in because people are generally at home. The recession is inevitably going to see there's less economic activity, and we are also likely to see greater wealth differentiation. So fuel poverty is going to become a greater issue than had been the case. We're seeing less travel. We're probably seeing less actual transport going on, and we're also seeing much greater distances for deliveries that will be happening, driven by online activity. And we're also like to see far more people home entertaining. I've been out to a restaurant once in 6 months. You know, that's a significant change in what is going on. And it's not just household, it's also the industrial and commercial sector. And we're seeing there'll be less energy used in facilities, buildings and transport due to closed premises, or even due to lower activity in premises. We're also seeing that there'll be less space for certain activities, and there'll be less available room in somewhere due to social distancing. Once again, more delivery, more e-commerce, and the greater demand in some positive market segments. So the point is that the analysis we have done does not necessarily give us a perfect example of what a future energy system is going to look like. So just turning back to this graph, finally, we do know something about what we've got to do with an energy system. And we really know that of the middle section here, which runs down from LPG down through to gas oil, the middle, we are going to have to make all this sustainably. At the moment, it isn't. It's all made out of fossil fuels, and we have to change that. And we are going to have to change that by a number of measures. In addition, the distribution of the shapes on the right-hand side will also inevitably change. And some of the ways in which we can make those changes will involve things like the use of hydrogen and also batteries. And that's a large part of what the Reflex project is doing, and which Gareth will talk about later. So this evening, we're going to look at a couple of particular areas which I think we can go into a greater detail, which will be covered by Richie, the upper section, and the ferries, which will be picked up by James. Both of these colleagues of mine at EMEC are working in particular areas. Richie specifically has now moved abroad, but they are looking in great detail at a number of facets, because we're trying to play our part in finding a way to deliver a new, truly sustainable energy system. So with that, I'm now going to hand over to Richie, who will take up the next section. Richie.
Thank you very much, Neil, and thanks for allowing me to be part of this year's Orkney's Science Festival. And it's great to be able to join in this virtual event from across the other side of the Atlantic. So as Neil mentioned, we're going to be looking at some hydrogen and aviation stuff. And if we take a look at those numbers of core energy use for Orkney, we can see that if we break it down into 3 core sections, transport is our #1 energy consumer on the island. When we break that down again, it's no surprise that marine transport plays a very large portion of that, and road transport almost equally as much. If you're in Orkney, you know that we have a strong passion for EVs, and there's been a big push for that in recent years, and we kind of have a technological solution for certainly passenger transport and road vehicles. James is going to talk a little bit about the maritime options that we might have, but I specifically want to touch on aviation. Aviation is now considered to be one of the most difficult sectors to decarbonise, and we have these net zero targets that we simply have to meet. This year, we saw the Clean Skies report that came out, and it highlighted that to achieve sustainable aviation and to allow us to continue to enjoy the benefits of air transport, hydrogen is a very key key potential option for powering these flights. The UK government just set up the Jet Zero Council, and it's also looking at ways to encourage sustainable aviation in the UK, and they're strongly considering hydrogen as being a very big player into that. If we look at the local use of air transport on the next slide, we can see that we do have a considerable number of passengers coming up to Orkney, and there is an argument that, well, we need to decarbonise air transport. Why don't we just reduce the amount of flights that we have? Do we need to be flying this often? Is it a luxury that maybe in a net zero world that we shouldn't be able to so easily afford? But when you start to think about it, a good portion of those flights that are coming up to Orkney are bringing tourists to visit the local area. That's a huge part of the Orkney economy. But probably more importantly, the smaller flights and connecting up our island communities and being able to offer quick and reliable transport is also incredibly important. We also have to have NHS patient transfer services for getting down to the Scottish mainland for treatment in hospitals. So it isn't quite as simple as just reducing the amount of time that we spend in airplanes and the amount of time we spend in the air. We really have to solve this situation and figure out a way we can reduce the CO2 production from air transport. Now, a project we've spent the last 12 months looking heavily into is the High Flyer project. And we are partnered with a great consortium. We have Intelligent Energy, which are a UK-based manufacturer of fuel cells that are looking at lightweight fuel cell supply for aviation. But the key project partner in the High Flyer project, if you just jump to the next slide, is Zeravir. Now, they are a US company that initially set up in California with the aircraft that's shown there, which is an M-class Piper aircraft. And what they did was they took out the traditional internal combustion engine run on jet fuel, and they swapped that out with a fully electric drivetrain. And their goal, and why they moved to the UK, was to then change that drivetrain into a hydrogen powered one. So the aircraft that's shown at the bottom, they came back over to the UK just over a year ago, bought a similar aircraft, carried out the conversion, and then last month they actually conducted a whole range of battery test flights for the full electric drivetrain for this aircraft. We're now at a position where we're trying to phase that into fuel cells, and we will be conducting hybrid tests, hopefully within the month, where we have half battery and half fuel cell operation of the aircraft, with the goal to reach 100% fuel cell hydrogen electric aviation. The target distance is 200 to 300 nautical miles, and Zeravir reckon that would service about 50% of the flights that are taken globally currently. So it's a huge market. It doesn't solve all the problems in aviation, but it's a huge part of it. And a big part for us is the potential of getting this aircraft up to Orkney later in this year and to replicate one of these commercial flights. So flying from Kirkwall to one of the well-serviced destinations on the Scottish mainland and prove that hydrogen in aviation is an option for reaching net zero targets. If we jump to the next slide, we can see that for EMEC, our key role in the project has been supplying the hydrogen, but we're also supplying the refueling equipment. So how are we going to get that hydrogen into the aircraft? So we went out to tender through public procurement, and we selected the guys down at Fuel Cell Systems, which are based down south. Now, Fuel Cell Systems had previously produced a mobile hydrogen refueling truck, and it's shown in the left-hand side of the bottom picture there. You can think of it very similar to the hydrogen refueling station that's stationed over at Kirkwall, with a little bit smaller storage and the added benefit that it's on wheels, so we can take it anywhere we want and service any hydrogen project. Now, this was designed and built to the J2601 standard, which is the globally accepted standard for hydrogen refueling in the automotive sector. The reason that we've had to use the automotive standard is the fact that there is no standards available for aviation, and this is a stepping stone to get to the point where we can try and outline what those might look like. It dispenses hydrogen at 350 bar and is capable of holding 55 kilos inside its 500 bar storage, which you can see in the image there. It's got benefits in the fact that it's compatible with multiple hydrogen sources, so we can charge this truck up with the tube trailers that you'll see driving around Orkney, transporting hydrogen, with MCPs or other bottled hydrogen gas. But we've also looked at producing hydrogen locally and feeding that directly into the truck as well. Another great benefit of this is the fact that it's a 7.5 ton road limited truck. Therefore, you don't need to have a heavy goods vehicle license to drive it. You only need a class 1 license, so it makes it a lot easier to be mobile and for our staff to move it around as required. And as I mentioned, we really see this as a stepping stone towards commercial aviation use. It's not just about trying to decide whether hydrogen is viable on a technical level. Can it actually meet the commercial demands and the quick turnaround times that we need in aviation? And we had a master's student this year look into that and assess whether the J2601 standard could be used for larger scale volumes of hydrogen that will be needed in the aviation industry. If we jump to the next slide, I mentioned that we have the potential of localized hydrogen production. So that's Nick, our senior electrical engineer, grinning away there. And this was a photo that was taken last week when Neil was going to, when Nick was producing hydrogen on site. We have this in a 10-foot container unit, and it's mobile and it's deployable at different locations. It's modular construction, so we can swap out the components if there's any issues with them, and we have full remote access and monitoring and control of the system. It only produces a small amount of hydrogen on a daily basis, so the goal is for this to top up the truck as it's used for the project deliverables. I should also note that it's capable of scaling, and the guys at Enapter just now are working on megawatt scale versions of this in containerized solutions. If we just jump to the next slide. So in terms of results from the project, I mean, the key thing for us is just learning by doing, trying to demonstrate these things in real life. And we're trying to gain that commercial knowledge of what might be possible with the use of hydrogen in the aviation sector. It's a practical demonstrator first, and we're hoping the Zeravir are going to achieve a whole range of world firsts, including the largest hydrogen aircraft, the longest commercial scale hydrogen flight, and most importantly, a zero emission hydrogen powertrain that they can offer to industry. And finally, I'd just like to state that it's been great working with EMEC and being involved in all these different projects. And the growth opportunities that we have are just fantastic. It provides a whole range of options for science and engineering jobs and science and engineering research specifically for Orkney. So one of the biggest opportunities that we're going to have, as James will discuss, is in the maritime sector. So I'll pass over to James now and he can discuss what might be capable of hydrogen there.
Thank you, Richie. If we can skip to the next slide. Yeah, thank you very much. So hi everyone. So as Karen mentioned, I'm at the closing stages now of my industrial PhD, which has been based on hydrogen supply chains. And what I'm going to do in this presentation is run through or give a very short introduction to one of my chapters, kind of give you the context behind it, give you some of the key results and some of the main, a summary of the main findings. So if we can first go to the next slide. The first question is, why use hydrogen? So as we look to decarbonize our energy use, we're seeing lots of new technologies or new applications for existing technologies that have each got different characteristics. So in the maritime sector and others, we're seeing that batteries are the most efficient, but they're the least energy dense. We're seeing that hydrogen is less efficient, but more energy dense. And we're seeing that ammonia is the least efficient, but the most energy dense. So the question is, which to use, which is best? As a very simple starting point, at the highest level, you can imagine that if a machine currently runs on petrol, in the future, it can go to batteries. If it currently runs on diesel, in the future, it can go to hydrogen. And if it currently runs on bunker fuel, in the future, it can go to ammonia. So Orkney's ferries are using marine gas oil, which is a bit like diesel. So we're going to be focusing on hydrogen in this presentation. So if we can move to the next slide, please. There's 101 different ways that you could set up a low carbon ferry network for Orkney. What I've envisioned is this plan shown here. So basically, we've got an electrolyzer near Kirkwall, specifically in Hatston. And the electrolyzer is the machine that takes the electricity and water and uses those to make hydrogen. So that's the machine that makes the hydrogen. That electrolyzer in Hatston can be powered by a nearby wind farm or a tidal farm near Edy. And the idea is that ferries can visit the electrolyzer if they're based in Kirkwall, and they can refuel there. Alternatively, if the ferries are based outside of Kirkwall, then a tube trailer can take the hydrogen from the store to, for example, Stromness. So that's the context. Yeah, so we can now move to the next slide. So the question is, if we're producing fuel and we're delivering energy in the form of fuel, the question is, how much do we need? So we know that Orkney's internal ferry service before COVID was using around 2.8 million litres of marine gas oil a year, which equates to around 30 gigawatt hours per year. That is on average the equivalent of 2.5 tonnes per day of hydrogen. For the main body of my analysis, I've used 1 tonne per day. So that's not enough for all of them, but it could be a good place to start. So the question is, what capacity of power supply, electrolyzer, and store gives the best unit cost? So we can move to the next slide, which introduces the results section of my talk. And here is the first result slide. So this is a 4D graph, which I'm very pleased with. It's for a wind-powered electrolyzer, which is using grid power as a supplement to wind power, and where electricity is procured as an operating cost. So what we've got is 3 variables as inputs. We've got electrolyzer plant capacity, store capacity, and wind farm capacity. And we've got one output, which is a unit cost. So each of those dots corresponds to a test, which I ran in my computer. And the color of the dot corresponds to the cost of the hydrogen in that test. So the darker, the better. So there's a few things that we can draw out from here. If we look at the electrolyzer plant capacity and the store capacity, what we've got is basically a compromise between maximizing our utilization of low-cost wind power versus minimizing our capital expenditure. So we want a big enough plant to capture lots of low-cost renewables power, but we also want to minimize how big it is so we don't need to buy one that's too big. So in this case, we're finding that a 3.5 megawatt electrolyzer and a 2-ton store is giving us good results. If we look at the third variable, which is wind farm capacity, what we're seeing is that as we increase the capacity of the wind farm, we're getting cheaper and cheaper and cheaper hydrogen. And that's because we are able to use more of this low-cost renewable power and less of the more expensive grid power. So in this case, the bigger the better, and we're getting the best unit cost at a 50 megawatt wind farm, which is coming out at £3.12. But we can change the scenario slightly by moving to the next slide. So here, we are no longer using grid power. And so this blank space that's now appeared corresponds to the cases which could not meet demand without using grid power. So the remaining ones are able to meet demand using only the power from the wind farm. So here, we're still sticking with our 3.5 megawatt electrolyzer. That's still good. But now we need at least a 5-ton store in order to meet that demand. And we're seeing a different trend on the wind farm capacity as well. So in this case, there's only one source of electricity, essentially, and there's only one price of electricity. So that means, provided that the wind farm is large enough, increasing its capacity further does not affect the unit cost. And so you can see each of these columns stays the same color throughout. The cost isn't changing as you change the wind farm capacity. So in this case, we're coming out as slightly more expensive at £3.67 in the best case. So that's focusing on wind predominantly so far. But if we move to the next slide, we can also look what happens when we include tidal power. So tidal power is relatively expensive, but it has the advantage of being very reliable. And one of the ways that we can quantify in terms of cost, the advantage of that reliability is we can ask big questions like, what would happen if there was a high pressure event and the wind stopped blowing for 2 weeks? So in Orkney, perhaps this isn't a very likely scenario, but you can imagine that these events will become important to consider as we move to a renewable-based system. So when there's no wind for 2 weeks and you are using power from the grid, there's not much change. But when there's no wind for 2 weeks and you're not using power from the grid, then we see a more dramatic change. So in the wind-only scenario, the cost shoots up to £6.18. And that's because we need a 17-ton store in order to meet demand. So we need a much larger store. Compare that to the wind and tide case, which is only £3.83, because we're able to get by with our 2-ton store. So we're all right there. Okay, if we move to the next slide, we can see another test that I ran. So this is the levelized cost of hydrogen. So this is a little bit different from the numbers we've seen before because I've included a few different things. But basically, this is for 1 ton a day without seasonal variation. So the levelized cost is £4.39. And what this tornado plot allows us to do is identify the factors which have the largest influence on the cost of hydrogen. So we're seeing that wind has the biggest cost, the cost of wind power. Next is the electrolyzer capex, and next is the store capex. So that allows us to say, if we're going to invest some time or some money changing one factor to bring down the cost of hydrogen, where should we direct our efforts? Okay, so on to the last slide. To summarize, my best results, or the best results, are obtained for a predominantly wind-powered electrolyzer, which is backed up with tidal and grid power. Depending on the scenario, seasonal variability in demand, and the size of a contingency store, the best costs are between £370 and £496 per kilogram. So in terms of fuel costs alone, cost parity is reached with marine gas oil at more like £1.40 to £1.89. So you can see that we've got a bit to go. That's not quite a fair comparison, but it gives an idea that we've still got to bring that cost down because marine gas oil is so cheap. So we're basically seeing that hydrogen is more expensive at the moment, but we can be confident that as these machines get rolled out, that the costs will fall. And in addition, on-board costs should be considered when doing a full systems cost analysis. That's the cost of the ships themselves and operating them. In addition to those direct economic factors, we should also consider the advantages of hydrogen, which include reducing emissions, improving air quality, as well as creating jobs and increasing energy security through establishing a local production and supply chain for ferry fuel. Thanks for having me at the Science Festival, and I'd like to now pass over to Gareth.
So, good evening. Neil showed very effectively how Oakley's got a huge job on its hands, not just to decarbonise electricity, which we've done over the last 20 years, but to now look at decarbonising some of these other fuel systems. And I think Richie and James have really shone a light on the work that's going on, particularly in the aviation and the maritime sectors, to start to look at those issues. And in parallel with that, the Reflex project is really looking at the overall energy system that we have in Orkney and seeing how this can be decarbonised. And I want to talk a little bit about that and put that in the context of perhaps a wider innovation hub idea for Orkney. So if we go to the next slide, please. So many of you in Orkney have hopefully heard of Reflex. Those of you further afield may not have heard about it yet, but basically what Reflex is to do at its simplest level is to link all of the renewable generation and the demand that we have in Orkney within a digital control system, and to introduce flexibility, to introduce storage and balancing services within that network to allow us to create an integrated energy system. And that energy system, if we go to the next slide, is going to consider all three major energy vectors. So it's going to look at electricity, it's going to look at heating and cooling, and it's going to be looking at transport. And so it's very relevant to the things that have been talked about, particularly by Richie and James. And some of the examples of the technology that we may be introducing through that are shown in the pictures here. So it's about looking at batteries, it's about looking at electric vehicles, it's about looking at smart storage systems in homes. It's about looking at hydrogen and the role that hydrogen can play within this energy system. And as I say, it's across these three vectors of grid, transport, and heat. Go to the next slide, please. So the program is over 3 years, and we're just over a year into it now. It's fair to say that the COVID events have kind of been a challenge for us, but we're moving towards a launch later on this year. And basically what we've done within this Reflex program is looked at that pattern that Neil showed very effectively about how the demand in the domestic and business sense for electricity dips at different times of the day and peaks at other times of the day. And working with Solo Energy, who've got a control system, they're going to be introducing batteries which allow us to modulate and load shift that load between these systems. We've also been looking with partners, a company called Fleet Drive, one of the largest suppliers of electric vehicles in the UK, to be able to introduce electric vehicles on a lease basis into Orkney, as well as being able to purchase them, and also working with Co-Wheels on a car club scheme so that you can actually get access to electric vehicles through that kind of mechanism. On the heat side, we're working with hydrogen and looking at how hydrogen can be used to support buildings as well as the ferries that James talked about, and also looking at how hydrogen might be able to be used for some of the more intense transport and mobility uses around heavy goods vehicles, buses, and agricultural vehicles. Now, one of the things that Reflex has to do is take all of these systems off the bench and out of the laboratory and put it into a customer format. So what we're doing is basically delivering a customer service, an energy service that people can get signed up for. And we've got 900 people in Orkney that have already indicated they're really interested in this. And we're looking to recruit people who, as we roll out the commercial service, can get involved in that. So we have two vehicles, commercial vehicles we're using. We call it Reflex Global, which is a company which will look after Reflex not only in Orkney but also in other parts of the world. And we've got Reflex Local, which will be essentially our local energy company. It's like a micro utility that's going to be set up in Orkney. And there's a load of interest going on locally, but also we're getting now increasing interest nationally and internationally about places that are interested in replicating this as we show that it can actually work. If we go to the next slide. So one of the challenges with energy is that for many years, as households or as businesses, we've basically been told that our sole responsibility is to achieve the cheapest supply of electricity to our household, and kind of nothing else matters. And that's why there's been the pressure for fuel switching. But energy actually impinges on so many different things in our houses and in our businesses. And so within Reflex, what we're trying to do is to see how energy as a service can attach value at all of these stages in the energy supply chain process. And that's creating some really interesting opportunities in terms of places where a lot of the value that we spend from our household budgets or our business budgets go into energy, but we're not actually recognizing that at the moment. So we're trying to illuminate that for people. Next slide. So as I mentioned, we've got these two entities that we're creating. We've got the global umbrella organization and then Reflex as a local trading organization. And that idea of decentralizing electricity supply and creating local micro utilities is key to this. And those of you that follow energy will be aware that there's a growing awareness that this decentralization of energy systems around renewables is probably something that's going to be a key focus in the future, and particularly for island communities and more remote communities like Orkney, but also in more urban settings as well. Next slide, please. So Neil posed this question earlier on about how are we going to move this energy transition from hydrocarbons to something that's decarbonized. And I think we started to see from what Richie and James showed how hydrogen can play a role, and there's also other areas where batteries and electrical power are going to be playing a role. Now, it's too early to say in exactly each case which one is going to be best, and in many areas it's probably going to be a combination of those. But Orkney is really at the heart of what's happening in that regard. Next slide. So, as well as having Reflex as an initiative which kind of commercializes energy services, we're also looking to tie together all of these things we've talked about as an innovation hub. Next slide, please. And as Neil said, Orkney has been at the forefront of centres of excellence for many years. There's a list here of the areas where Orkney has developed centres of excellence going back to even to the 50s, really, when wind testing started. There was a period in the 60s and 70s before the flotter terminal and the energy side kicked off. But there's a lot of activities that have gone on over the years, and there's a lot more that are coming at the present time. Next slide. And so one question that we get asked is, well, why Orkney and how is it happening in Orkney? How does a community of 22,000 people support this numbers of centres of excellence? And part of it is political, part of it's geographical, part of it's about the spirit of Orkney and the opportunities that the resources in Orkney give us. And it's really taking all of those assets and putting them together in a package. And perhaps because we're an archipelago of islands, we're not just one place. We actually have a lot of the dynamics that affect much larger land masses and more complex systems. But what we see is at the scale that Orkney operates, we can accelerate transformation at an affordable scale. We can road test things which are going to be rolled out more widely. And this idea of Orkney being a living laboratory is something that we've proven again and again, not only helps the technology and innovation, but it helps the community by creating jobs as well. So basically what we're hoping to do or helping to do is make things happen smarter, faster, and greener. Next slide. So very recently, this idea has been put together in the idea of what's called an innovation Freeport. And the current government, UK government, is very interested in the idea of Freeport development. And translating that into an Orkney sense, we see three themes: one around energy, one around transport, both of which we've talked about, and digital enterprise, which is going to be crucially important across a whole range of economic activities. And so this economic Freeport would give us the recognition that we are a centre of excellence in these areas. It would give us the mandate to lead innovation in these areas, and the regulatory and fiscal flexibility to explore new solutions, which aren't following the old ways, but they're actually looking at new ways of developing these things. Next slide. And an example of that in the hydrogen space, and taking the work that you've heard, particularly from James and further forward, is could we use our ferries, our work boats and our fishing boats effectively as test beds, where some of these new propulsion systems could be fitted effectively as Lego blocks. So the boats are designed specifically so the propulsion system can be taken in and out very easily. It means we can be road testing new technologies and see how they work at an early demonstration stage, and then that can be rolled out at a more commercial level afterwards. That's an example of the kind of innovation hub being put into action. Next slide. So if we think then about how this plays into our energy system, this is back to the Sankey diagram that Neil showed earlier. Click again, please. So we've already transferred our electricity into renewables, and we need to do that other part of the stack, the other 85%. Next slide, please. And that's going to be a combination, and transport's going to be a big part of that. Next slide. And that's going to involve a combination of batteries and hydrogen. And as I say, we don't know exactly how that's going to play out, but it is going to be a combination of those things. And Orkney is already, as you see, making progress in these areas, and we're going to make more and more progress going forward. Last slide. So why are we doing this? We're doing it because we have to decarbonize Orkney. And the reason we have to decarbonize Orkney is that we need to decarbonize the world, and we can't just do that magically. We have to have communities which can be lighthouse communities that can show a way for other people to follow. Now, Orkney's been on that path for a long time. It means that instead of adopting the UK target of 2050 or the Scottish target of 2045, we need to go for something much earlier. And at the moment, our working hypothesis, if you like, our working target is that we need to decarbonize Orkney by 2030. And so all of these things that you've been seeing today need to be applied early to get us there smarter and greener to the world that we want to have. So that's the end of my bit of the presentation. I'd now like to hand over to Karen, who I think is going to lead us through some Q&A.
Thank you very much, Gareth, and to Neil, Richie and James for some really interesting presentations. And it's just very exciting to see developments which are happening on our doorstep. So I'll just start off the Q&A session. Following on from Gareth, we have a question for you, which comes from Richard Oakley. And it's, what developments in battery technology do you envisage as being the most helpful?
Yes, so that has brought up the topic that we haven't discussed today, but clearly, as alongside hydrogen, there's a huge amount of investment going into batteries. I'm not an expert in it, but my awareness of it is that there's chemistry that's being looked at. So lithium ion is our classic battery, or lead acid used to be our battery. So people are looking at the chemistry of batteries, but they're also looking at the production techniques, the intelligence that batteries have themselves. Batteries are now produced with chips inside them to give feedback about the state of the chemistry. These can allow them to be run much more effectively, because instead of just assuming it's at a certain temperature or it's in a certain state, you actually get data on it. So things like chemistry, things like production, things like smart batteries are all making them more effective. And the cost is just collapsing at the moment. And particularly the Chinese, the amount of batteries they're producing, the quality is increasing, the price is coming down. That's really influencing the whole market. Neil.
Yeah, and the other thing is, I think we need to think about how we store a variety of things. And one of the things we need to think about is what we're going to use the energy for once we take it out of the store. And heat is the classic one that we seem to be completely blind to. So storing energy is hot water is really easy and is really effective. And I'll give you a very simple example. If you take a ton of water and move it 100 meters into the air, that will store 1 megajoule. If you leave that same ton of water on the ground and heat it by 60 degrees centigrade, that will store 240 megajoules. And the point is, keeping a ton of water 100 meters in the air is really hard. The pump water storage, you need a convenient mountain. But whereas keeping a ton of water on the ground and warm just needs a duvet. So I think we need to recognize that there are some very simple storage technologies. But of course, a ton of hot water is only any good for heating your house. It's no good for running your laptop. So you've got to decide what it is you're using, why are you storing the energy, and what are you going to do with it afterwards? So we need to think down the pipe as well as just the storage.
Great, thank you very much both. I'll take my next question over to Richie, coming back to aviation. I've had a couple of questions there. And this one came in from Richard Oakley, just about what methods or what measures are being used to ensure that hydrogen flight becomes a financial success, not just a developmental success to the UK.
Yeah, thanks for the question, Richard. That is a really important part that we are seeing in these demonstration projects these days. It's not just about being able to prove what is technically viable. It has to have an end point. And we realize, as Gareth's alluding to as well, that this end point is getting closer and closer, and we really need to get there. We see with the funding that's available through the Aviation Technology Institute, which is a kind of branch of BASE, so the government providing money into R&D funding, the UK aviation industry is huge, and they are very concerned about the fact that they can see some really real cliff edges for what's going to happen in the near future. So I feel like that's already there. Like, part of these proposals and these bids that we put into projects, you really have to show that it's not just a one-trick pony. There is an actual plan to reach the next stage. With the High Flyer project, Zeravir as a company have a very structured commercial plan on how they're going to develop this net zero powertrain and how they're going to scale it up for larger aircraft and take it to the next stage. So it's very much front and center of particularly what the politicians are looking at the moment.
Great, thank you, Richie. Staying on the topic of hydrogen, but kind of honing in on cost and price of hydrogen, I've got a question for James in from Donald Sinkler. And just that if the grid shifts to largely renewable energy and the price alters accordingly, well, how would that affect the figures that you had there in your presentation?
Yeah, thanks for the question, Donald. So in the analysis that I showed you, everything was at a fixed cost. So the wind power was fixed, the tidal cost was constant, and the grid cost was constant. So that would be suitable for something like a power purchase agreement or a contract for difference. But that idea of interacting with the grid is really interesting. We saw from the tornado sensitivity analysis that the electricity is one of the main costs in electrolysis. And what we're seeing across the UK is that as we see more wind power and renewables come onto the grid, we're actually seeing times when the price goes negative. It could actually be the case that we could get paid to make hydrogen. So that's actually an interesting question for further study. So there are some people who have plugged electrolyzers into the grids and have interacted with the markets in those different ways. So that would be a very interesting question to explore further for us in Orkney.
Great, thank you, James. Neil, do you want to chip in there?
Yeah, I do. I think Gareth wanted to say something as well, but the National Grid produced a series of things called future energy scenarios. The last one was produced about a month ago, and it looks at different ways in which the grid could develop over time. They're talking about having 80% of the equipment generating on the grid by 2040 having zero marginal cost of generation. In other words, you built it, it just works. The sun comes out, you get more electricity, sun goes in, it stops generating, but you don't keep shoveling coal into it. So there's going to be a massive change in the way electricity is valued. And so this is why James's models are so helpful to understand the sensitivity to what you need to do. So you can spend a lot of time pushing something and making it absolutely perfect, but if you're tackling the wrong target, then you're wasting your time. So having an understanding of where the costs are coming from like this is really helpful.
Gareth, do you have anything to add? Or?
Well, it was just that's kind of both the challenge and the opportunity that Reflex is targeting as well, because what we're trying to do is to bring that value to bear to help all of us. So it's not going to be some different person that's dealing with the flexibility. It's you as a householder or you as a business that you're actually having, as Neil said, we're not going to be having somebody else looking after this. Everything that we have in our energy sphere is going to have built-in flexibility and capacity to optimize itself. So basically what Reflex is doing is accelerating the availability of that to us in Orkney as a community, and that's one of the major opportunities and the innovations that's coming.
Great. I think we'll maybe have time for one more question, so I thought I'll circle back to Neil's presentation at the beginning. This is a question about the energy landscape in Orkney and particularly about the farming sector. The question from Fiona Graham, which is, did the use of energy in the farming sector in Orkney remain the same? I think this is with regards to, COVID pre and post. And is the energy revolution reaching the farming sector and making changes there?
So to answer the last part first, it's not reaching it completely at the moment. I mean, there's been quite a revolution because a number of the wind turbines that have been put out there are on farms and are generating revenue. I've got a figure in my head, so this is not suable, but this is I think Erlen Tate said a while ago that he'd been told that a 20 kilowatt wind turbine was giving roughly the same revenue as 20 suckler cows. So there's a definite measure that we can make, and of course the advantage of the wind turbine is it doesn't really take up much ground. So there is a lot more that can be done in the agricultural space. It's certainly not got there yet, and if somebody knows somebody with an electric or a hydrogen tractor, get them in. Let's talk to them, because we'll find a way to use it, because you saw how big a piece that is. So there is a lot to be done there in that space, and that's even before we start to go to things like vertical farming or indoor farming, where we're working with LEDs and sort of getting out of the weather. So there's so much that can be done. Energy it underpins everything we do now, and it's going to become even more central, and I think people are going to start to see it. Be aware of energy in a way that I've not seen for a generation.
Wow, exciting things are happening here in Orkney, and it's great that we're in the forefront of these developing systems. I want to thank you, Karen, for co-hosting, and to our speakers, Neil, Richie, James and Gareth, and also all our online participants. We didn't have time for a lot of questions, but what we'll do is we'll make sure that we forward these to the speakers, and we'll post up the answers later on the website. And I'd like to thank our technical team for their hard work behind the scenes. And please join us all again at 9 o'clock tonight. Our next talk will be Music for the Winter Queen with Howie Firth. And there's still spaces for our PD Kirk lunches this week. If you'd like to relax and chat around one of our virtual tables with some of the festival speakers, please see the links below each event on the website. We'd also like to invite you to join us later tonight at the Festival Club from 9:30. Please copy the link that you should have got in the live chat and come in by and see us. And remember to like our Facebook page and follow our channel if you're enjoying what you're seeing. I know I certainly am. And lastly, good evening and goodbye.
Thank you.
Thanks very much.
Bye.